This video is going to look at the vocabulary that we need moving forward in order to talk about how we can analyze an event that has multiple different actions in it. So let's go through some our vocabulary. First, we have a tree diagram. A tree diagram is an illustration that uses branches to show the sample space of an event. Okay, so when we have multiple different actions that were occurring, or maybe multiple different choices we need to make, we can use a tree diagram to help us map out our choices. Space then is just the set of all possible outcomes of an event. So if you think of rolling a number cube twice, we're going to have a certain number of outcomes. We can get a 1 and then a 1, a 1 and then a 2, a 1 and then a 3, and so on. So the tree diagram is going to help us visualize all of the possible outcomes, which are called sample space. Now there's an easy way for us to figure out the total number of possible outcomes, and that's through using the fundamental counting principle. And the fundamental counting principle tells us that if there are m ways to do one thing and n ways to do another, then there are m times n ways to do both. So in other words, to find the total number of outcomes, we multiply the total possibilities for each part of the event to find the total things in the sample space. So if we're talking about rolling a number cube twice, the first time we roll it, there are 6 outcomes. The second time we roll it, there are another 6 outcomes. The fundamental counting principle tells me I should multiply, so there would be 6 times 6, or 36 total outcomes. Now, there are different terms we can use to describe the event or the game, some of which we've already talked about. First, it's a fair game, and a fair game is a game where all players have equal chances of winning. So this was the goal that Calvin and his mom wanted to create a fair game so that it would be random what cereal Calvin eats, but it would also be equal chances to eat either type of cereal. Now, some of the games that Calvin did turned out to be compound events, in which an event or a game is made up of 2 or more individual events. So, for example, when Calvin spun the spinner twice, that's a compound event because he had 2 events of spinning the spinner twice. If we roll a number cube twice, we have 2 events, the first time we roll it and the second time we roll it. So we call overall it a compound event. And we use the fundamental counting principle and tree diagrams to find the total number of outcomes and the possible outcomes in the sample space for compound events. The last 2 words we've already talked about would be possible versus probable. And we'll just review them once again. But possible means an event could happen. So remember that even if there's a very small chance, there is a chance that it could happen. Probable means that it has a fairly good chance of occurring. Typically we would call it more than 50%, and the higher the probability, the more probable it becomes. What we're going to do next is take a look at an example situation, an example event, and apply these different vocabulary words. For the examples, you should go ahead and put this on the back of the graphic organizer. All right, let's take a look at an example. Let's say our situation here is, say I walk into my closet in the morning and I see 3 different shirt options that I could wear. Let's say there's a white shirt, a red shirt, and a blue shirt. And there's 2 different options for pants that I could wear. Let's say I have black pants and tan pants that I could wear. Let's walk through our different vocabulary in order to understand this situation. So first thing we can do is make a tree diagram. And a tree diagram, again, is an illustration using branches to show the sample space of an event. So the first thing I'm going to do is I'm always going to start at a point, and we call it the starting point. Okay, I'm just going to label it with S. Now off the starting point, I'm going to put my first options. My first options are 3 shirts: a white shirt, a red shirt, and a blue shirt. Okay, and you can write out the whole words. You can label it shirts up top, whatever you feel you need to do. Now I have 2 options for pants. So off of each of my shirts, I'm going to have 2 options for pants. It's either going to be black pants or tan pants off of each of these. Black pants, and I'm using BK for black to differentiate it from blue, or tan pants, and once again at the bottom I have black pants or tan pants. Okay? These are all the different options. If I were to have something else, I could branch off of each of these options. But these are all of my different options that I could wear. The very right side of this is called my sample space. It's everything out here that is a possibility for me. So all of this right here, when I read across, would represent the sample space. So in this case, there are 1, 2, 3, 4, 5, 6 options in my sample space. Okay, 6 options. And remember, we said that we could use the fundamental counting principle to find this. If we take the number of shirts as 3 times the number of shorts or pants, which is 2. That would still give me 6. My different options are found by reading across the branches. I have a white shirt and black pants. I have a white shirt and tan pants, and so on down the list. I'd have red, black, red, tan, blue, black, blue, tan for a total of 6 different options. Okay, so this is my tree diagram over here. It's my tree diagram. The total number of outcomes is listed here, and the list of them is called the sample space, which would be this over here. I can use the fundamental counting principle, take 3 times 2, which gives me 6 total options, which is verified by counting the last column in my tree. Right? Now, we wouldn't really use a tree diagram, or we could use a tree diagram to talk about the fair, whether it's fair. We can't really talk about that in terms of situations. All of these would have the same probability of getting picked, theoretically, looking at the tree diagram, but we would talk more about a fair game if we're actually talking about a situation like Calvin's cereal, and we'll talk about some of those examples in class. Hey, this is an example of a compound event because I had 2 or more simple events. I had picking a shirt as one event and picking pants as one event. So that's 2 events, makes it a compound event. Hey, all of these choices are possible. It is possible for me to wear a white shirt and black pants, but it's not going to be probable because that is not above a 50% probability. So most of this we've already talked about. The new things are the tree diagram, sample space, fundamental counting principle.